Hi there. Here's my solution to question 6.101. So, blood types. What is the probability of type AB blood in the United States? Well, all of these likelihoods have to add up to 1. So if I take 1 minus the 0.45 minus 0.4 minus 0.11, that gives me the likelihood of, in part A, the probability of type AB. That's 0.04. We're done with that one. So part B, an individual with type B blood can safely receive transfusions only from persons with type B or type O. What is the probability that the husband of a woman with type B blood is an acceptable donor for her? So she can only receive blood from types B or O. So these do not overlap. You are either type B or you are type O. So in this case, we can just add the probabilities together, the 0.45 and the 0.11 for type O and type B, and we're good to go. So that's 0.56. So for part C, what is the probability that in a randomly chosen couple, the wife is type B, the husband is type A? Now, we do have to make an assumption here. We are looking at this probability. Wife is B, and husband is A. The assumption we're going to have to make here, this is an and probability. So in order to calculate this, I don't have any conditional probabilities given to me, so we need to assume that the blood type of the wife and husband are independent of one another. So we're going to assume blood types are independent. Blood types are independent between husband and wife. Now, under this assumption, we can proceed with the calculation because this is an and calculation. So this probability then is simply the probability of a type B times the probability of type A. So type B from the table is 0.11. Type A from the table is 0.40. And under the assumption of independence, I can multiply those together. That makes 0.044. Now, understand in part C, we assumed it was the wife that was type B and it was the husband that was type A. The difference then in part D, what is the probability that one of a randomly chosen couple has type A blood and the other has type B blood? So notice in part C, we assumed specifically that it was the wife with type B and it was the husband with type A. Now notice the calculation is going to be exactly the same if we switch this so that it is the husband that is type B and the wife that is type A. We're still going to end up taking a 0.11 times a 0.40. So this is in part D, the probability that the husband is B and the wife is A. That probability is going to be exactly the same. It's still going to be a 0.11 times a 0.40. That's going to give us the same value. But the point is this, either one of these could occur. So in part D, wife B, husband A is possible, or husband B, wife A is possible. So ultimately our answer is found by taking the 0.044 and doubling it, or adding 0.044 to 0.044. That gives us 0.088. That's what we're looking for in part D. And then last, part E. What's the probability that at least one of a randomly chosen couple has type O blood? Well, here we go. So, the probability that at least one has type O. At least one has O. Well, there are a couple of ways to do this. I see this when I see questions that have the phrase at least in them, I tend to think of them as complements. This is the same as 1 minus the probability that neither has O. So again, under the assumption of independence then, that's the probability of O complement. So the first spouse does not have type O blood, and times the probability of O complement. The second spouse does not have type O blood either, so I need to go to the table. The likelihood of having type O is 0.45, so the likelihood of not having type O is 0.55. So I could think of this as 1 minus 0.55 times 0.55. That is one way to approach this. That comes out to be 0.6975. There you go, 0.6975. So that's my take on question 6.101. The likelihood of not being type O then, notice we got to go all the way back up here to the table. The likelihood of type O is 0.45. So the likelihood of not being type O is 0.55. So here we go. 1 minus the 0.55 times the 0.55. But be careful, something to think about here, the order doesn't matter. So something that we saw in the previous question, and that's the reason that the information is organized the way that it is. So understand, husband being B, wife being A, husband being the B, wife being the A. Either way, it's that same probability doubled. So we're going to have to account for the same thing in this question also. So the husband could be the 0.55, the wife could be the 0.55, or it could go the other way. This could be the wife and this could be the husband. So we actually have two of those that we need to consider here. So I've got 1 minus 2 times 0.55 times 0.55. That gives me 0.395.